Let's say a new iPhone is launched and every person on earth is lining up outside an Apple store. Now, if every person were the size of an atom, the entire human population of earth would shrink to a length of less than 1 meter long. That's how small an atom is. I am Nitin Verma, a chemistry faculty at Infinity Learn by Sri Chaitanya, and I welcome you all in this session on mole concept. So my dear students, together we shall be learning about mole concept, which is a very important topic for JEE main as well as advanced. We shall be learning the concept as well as taking up numericals for practice and some numericals from previous years. So let's get started. As I just told you that an atom is extremely small. It's so small that you cannot even see it with a simple microscope. So how to measure the mass of something that is vanishingly small? Okay, so we need a very small unit. So scientists over the time have defined several units. For example, earlier scientists have used hydrogen 1 and oxygen 16. Why am I writing the atomic masses? Because there are various isotopes of an element. So hydrogen has 3 isotopes. Scientists selected the one whose atomic mass is 1 unit. Likewise, in case of oxygen, the isotope whose mass number was 16 was selected to define atomic mass unit. The current reference to define atomic mass unit is carbon 12. Carbon 12 is the most abundant and stable isotope of carbon. So you can see carbon 12 contains exactly 6 protons and 6 neutrons, right? That is how the mass number of carbon is 12, because we know the mass number of carbon is equal to the sum of number of protons and the number of neutrons, right? So what did scientists do? Because the one atom of carbon 12 contains 6 proton and 6 neutron, so they gave it atomic mass of 12 AMU, right? Because the mass number of carbon 12 is 12, scientists assigned it a mass of 12 AMU. So how do we find 1 AMU? See, one atom of carbon 12 contains 12 AMU. So how do we define 1 AMU? Obviously, 1 AMU is 1 by 12 of mass of C12 atom. I hope it's clear to you. Am I right? So we substitute the mass of carbon atom. You don't have to worry about how this came. Scientists have measured it. Alright. So the mass of one carbon atom is 1.99 approximately into 10 to the power minus 23 gram. So this gives us this gives us the value of 1 AMU, which is 1.66 into 10 raised to the power minus 24 gram, right? Because 1 gram is 10 raised to the power minus 3 kilogram, you can also express it as this 1.66 into 10 to the minus 27 kilogram. Alright. So you should remember this value by heart, because in mole concept or in some relevant places we will be frequently using this value. Is that okay? So you should also know that the symbol of atomic mass unit is AMU. Alright. It is also called unified mass. For which the symbol is U, and although they are just merely for information, but you should know that AMU is also called Dalton. That is 1 AMU is 1 Dalton, or you can also call Avogram. History, chemistry is also a little bit about history, right? So when we learn some concept, for example in atomic structure, we learn lot of models which have now been replaced by the current model, but okay, there is some relevance and so we study them. Alright, so likewise in atomic mass unit, these are some names you should remember, okay, because they are relevant. So I hope you have understood 1 AMU and 1.66 into 10 to the minus 24 gram or 10 to the minus 27 kilogram. Okay, so now it's the time to flex your brain muscles. It's time to solve a question. So there is a question in front of you. Calculate the mass of one sulfur atom, and the answers are in gram and kilogram. Alright. I would like to tell you one thing. If you think that I am going a little fast, then after this class is over, you can like head over to the video and change the playback speed to 0.75. And if you think that this concept is basic to you, you can watch this video at a higher playback speed of maybe 1.25. That way you won't miss anything and you will save on your time also. Okay, so sulfur is a pretty common element, alright, and we all know the atomic number of sulfur is 16 and its mass number is 32, alright. So the atomic mass of sulfur is 32. Atomic mass of sulfur atom is 32 AMU or 32 U. But you can see in the options, none of the options contain AMU unit. In fact, all of them are in either gram or kilogram. So we would have to replace the unit of U by its exact value. So I can also write this answer as 1 AMU is, as we learned, this. In chemistry, sometimes the students complain, sir, in physical chemistry there is a lot of calculations. But I think you can minimize the calculations by just doing rough calculation. For example, in this particular question, this number is 16 or approximately 17 and this number is 32. So when I multiply 1.7 by 32, it comes somewhere around 4.8 or 5 something. So I can, okay, so this cannot be the correct answer. And this cannot be the correct answer, right? We have eliminated two options, that 2.6 and 32, that cannot be the correct answers. Now, how much is this? So this is approximately 50, right? And this is 10 raised to minus 24. I'm not doing any exact calculations, right? I'm saving my time. It is taking me longer because I'm explaining it to you, okay? So this is can be written as 5 into 10 raised to the minus 23 gram. And I have two options, this one and this one, but it's matching none of these options. So I would want to convert this into kilogram, right? So in kilogram, this can be written as 5 into 10 raised to the power minus 23. And 1 gram is 10 raised to the minus 3 kilogram. Is that clear? So this is 5 into 10 raised to the power minus 26 kilogram. So this is what our correct answer is. So option B is the correct answer. Is that okay? Now before I move on to the next question, I would like to tell you something. Atomic mass of sulfur is 32 U and atomic mass of sulfur is 5 into 10 raised to the power minus 26 kilogram. What is the difference between these two values? The atomic mass of sulfur is also 32 U and it is also 5 into 10 to the minus 26 kilogram. What is the difference between these two values of the atomic mass of sulfur? You should know that because this term is very common. When you use U, this is called the relative atomic mass because it is defined with respect to carbon 12. Right? When we say 32 U, which means that the mass of one sulfur atom is 32 times the 1/12 of the mass of carbon 12 atom. Seems a pretty complicated, right? I will repeat it for you. Mass of one sulfur atom is 32 times the 1/12 of mass of carbon 12 atom. But when we express the mass of an atom in kilogram or in gram in this value, and when it looks like this, that's 5 into 10 raised to the power minus 26 kilogram, it is the exact mass of the atom. It is the exact mass of the atom. Now you can appreciate why did scientists define atomic mass unit. Imagine if you do physical chemistry and every time these sorts of number come up. Every time you do calculation and there is something into 10 or minus something, it would become so tedious and the calculation will become very lengthy and boring maybe. So scientists have defined relative atomic masses. It's very easy. 32 is a very small number to deal with, right? So when expressed in AMU, the masses are called relative atomic masses, and when expressed in gram or kilogram, these refer to the exact mass of the atom. Can we move forward? Okay. Yes. A decent question. The mass of an atom of element M. There is some element, say M. It forms a compound MCl with chlorine. So can we infer one thing? Chlorine forms chloride ion, right? So this metal must be forming M plus ion. If it is a metal or if it is a non-metal anything, it would be having +1 charge, right? So it has a valency of 1. With chlorine is 1.05 into 10 raised to the power minus 22 gram. You have to identify the element. Now how do we identify the element? Can you tell me the most fundamental property of an element? Of course, we shall be learning it in future classes. For that, you will have to join Infinity Learn courses. For now, you can tell me what is the most fundamental property of an element? Yes, it is the atomic number, right? Atomic number is the most fundamental property of an element. Now, if not the atomic number, what is the second property? Atomic mass. I can also say that in many cases, atomic mass can also be used to identify an element. Okay, how? We shall see in this question. It is given to us that the mass of one atom is 1.5 into 10 raised to the power minus 22 gram, right? Obviously, it is the exact value. Let us find out the relative atomic mass of M. Can I divide it by AMU, right? Because the value of one AMU is 1.66 into 10 raised to the power minus 24 gram, right? It can be expressed as 1 AMU. I hope that's clear to you. This is the mass of one atom of M and this is the value of AMU, right? So if we do the little dimensional analysis here, gram gets cancelled out and we have AMU in the numerator. So I hope by now you have calculated this value. This works out to be how much? This is approximately, I think, 60 something, right? It's something like 60 because if 24 goes in the numerator, it becomes 24 minus 22, that is 10 raised to the power 2, which is 100, and this is I think 0.06 something, right? You can work it out, it's simple mathematics. So this gives us approximately 60 AMU. See, I always avoid doing exact calculations if I know that the chances of error are minimum. So the atomic mass of the element M is approximately 60 mu. Now let us see here, the atomic mass of sodium is approximately 23, right? It's not that you have to memorize the entire periodic table, but I believe that there are a few elements of which you should remember the atomic number and atomic masses. The atomic mass of iron is approximately 56. The atomic mass of copper, I hope you all know that because it is fractional, right? It is non-integral and we'll come to this. And the atomic mass of hydrogen is 1. So obviously our correct answer is copper. So copper is that element whose chloride we are talking about here. The compound is CuCl. Is that clear, right? So our answer is copper. I hope this question is clear to you. See, sometimes it's not just about the competition. I believe that if you put all your heart into learning something, it automatically comes to you. So whenever you learn something, always don't think, okay, if this is going to be there in NEET JEE, you learn it if it is relevant, right? It will help you build a strong foundation of that subject. So I think we should move forward to the next question. Okay, now it's actually a topic, average atomic mass. As I just told you that the atomic mass of copper is 63.5. But in previous classes we have learned that the atomic mass refers to the sum of protons and neutrons. Is there something wrong with this line that the atomic mass of an element refers to the sum of protons and neutrons? Yeah, you should not let anybody trick you with that. The sum of protons, the sum of number of protons and neutrons is not equal to the atomic mass. It is equal to the mass number, right? It gives you the mass number. So by default, it's a number. It cannot have the units of mass. So the atomic mass of chlorine is 35.5. We know that like since 8th class, and then we later learn, okay, copper also has non-integral atomic mass, then boron also comes. So how do these atomic masses arise, right? So these are actually the average atomic masses. What is an average atomic mass? In this session, I'll tell you in detail with some questions. So right in front of you is the definition. You just take a moment to grasp this. Average atomic mass refers to the weighted average of the masses of the isotopes of an element. Almost every element occurs in the form of some isotopes. For example, chlorine has two natural isotopes, Cl35 and Cl37. So if I pick a random sample of chlorine from nature, it will essentially contain both types of chlorine atoms. That is, it will contain Cl35 as well as Cl37. What do we mean by this is that any sample of chlorine will contain atoms of two different masses. So the average mass of a chlorine atom will be the weighted average. Weighted means you have to take into account their abundances. That's very clear. When we say weighted means you have to consider the ratios, right? So average atomic mass of an element is the summation over two terms. First term is abundance of an isotope and second term is relative atomic mass. And you obviously divide this number by total abundance, which may be a fraction. If it is if the abundances are expressed in fractions, then the total abundance will be 1, and if the abundances are expressed in percentages, then the total abundance will be 100. So I have written a general formula, right? Okay, to elaborate this, let me take an example. For example, boron. We all are familiar. It is a non-metal with atomic number of 5. Naturally, two isotopes of boron are found. B10 and B11. That is, one isotope which has a mass number of 10 and another has a mass number of 11. Now, by calculation, by measurement, the atomic mass of the percentage of B10 is found to be approximately 20%. That is, any sample of boron taken from nature is likely to contain approximately 20% of B10. So obviously this will constitute 80%. Alright, 20% B10 and 80% B11. So now we can calculate the average atomic mass of boron. It will be, the abundance of isotope is 20 and the relative atomic mass is 10. For the second isotope, abundance is 80% and the atomic mass is 11. This number gets divided by 100 because in percent the total is 100. So this comes out to be 200 and this comes out to be 880. This is equal to 1080 divided by 100 and this gives us 10.8. So average atomic mass of boron is 10.8 AMU or U. For numerical calculations, we usually take it to be 11, right, because that simplifies things. So now you can see that I could have also expressed 20 and 80 as 1:4, right, because 80 is 4 times 20. So I could have also taken that boron 10 and boron 11 occur in the ratio of 1:4. Is that clear? Right? 20 and 80 can also be written as 1:4. In that case, I would have expressed the average atomic mass as 20 into 1 plus, so I would have, because its percentage abundance is 20 and 80 and I converted it to 1:4, so I can write 10 into 1 plus 11 into 4. In that case, the denominator would have been 1 plus 4. Alright, now if you work it out, it will come out to be same, that is 10.8. Alright, so that is about the theoretical part of average atomic mass. Over the years, some questions have been asked in JEE, so let us take some of them. Can you imagine, this is such a straightforward question has been asked in IIT Advanced in 2009. Go through the question and calculate the answer. Given that the abundances of 3 isotopes are given, their masses are 54, 56 and 57. And the percentage abundances are 5, 90 and 5. And you have to calculate the average atomic mass of iron. Alright. Now if you want to solve this question by yourself, just pause the video. If you are watching the recorded video, just pause the video, solve a question and then replay it and cross check your answer if it is correct. Meanwhile, I am solving it. The average atomic mass of iron is 54 multiplied by 5 plus 56 multiplied by 90. See what I am doing, I am multiplying the percentage abundance by the isotopic mass, the relative atomic mass of the isotope. So 54 into 5, then 56 into 90, and finally the third isotope is 57 multiplied by 5. And because these are percentages, they sum up to 100. This is no big deal, you can calculate it. The answer will come out to be 55.95. Is that okay? So see, concept is concept, and a concept never gets outdated. Alright, even 50 years from now, the formula of average atomic mass is going to remain the same. So do not think that something is easy, it will not come in exam. No, examiner can ask you anything, right? And it is often the simple things that deceive you. We tend to take simple things lightly, and we tend to forget them, and they are the ones that harm us. So do not take simple concepts lightly, okay? Revise each and every point by heart. So this is one question that we have practiced. We can take another example because these questions have been asked over the years. Okay. This question, and there is some element Z. It has two natural stable isotopes. Their mass numbers are 36 and 40. The average atomic mass of the element is given. It is 38.4. And we are asked the percentage abundance of Z, whose mass number is 40. Okay. So just like in algebra, if we don't know something, we assign it a variable x, right? That's pretty simple. So what is the percentage abundance of 40x? Let's give it a value of x. The percentage abundance of 40z is x. Then the percentage abundance of 36z will be how much? Because we are talking about percentage abundances, the sum will be 100. One of them is x. The another one will be 100 minus x. Is that clear? Now the thing remains to substitute the values. The average atomic mass of the element is given to be 38.4. That is the average atomic mass. Now we will multiply the relative abundance by the mass of the isotope. Relative abundance of 36 is 100 minus x, and its mass number is 36. For the second isotope, the abundance is x and its mass number is 40. Is that clear? Right? So when worked out, it is 3840, open the bracket, it's 3600 minus 36x plus 40x. Alright, this can alternatively be written as, this is 3840 minus 3600, and it is how much? 40x minus 36x is 4x. This is how much? 240 is equal to 4x, so x is equal to 60. That is your answer. Right? So the abundance of Z40 is 60%. Is that clear to you? I think these many numericals are sufficient. Now I hope you have a fair idea of the average atomic mass. Now let's head over to molecular mass. As the name indicates, molecular mass is the mass of a molecule. Alright. Now before I start, let's understand this. NaCl and HCl. Can you tell me a similarity between these two substances? Apart from that, both of these contain chlorine atoms, that's very evident. One similarity about NaCl and HCl. Okay, see, the property you tell me should be an important property from the perspective of chemistry, right? So one similarity between them is both of them are strong electrolytes. Both of them are strong electrolytes. That means when we dissolve NaCl in water, it breaks down to give Na plus and Cl minus. And when we dissolve HCl in water, it breaks down to give H plus and Cl minus. Now, what is the difference between them? Both NaCl and HCl are strong electrolytes, right? So they are strongly conducting, their aqueous solutions are strongly conducting. Now, what is the difference between them? I am going to tell you something very basic but important. NaCl, when dissolved in water, it dissociates. The process of breaking down of sodium and chloride ions from NaCl is called dissociation of NaCl, whereas in case of HCl, it is called ionization. अब आप बोलोगे सर दोनों का मतलब सेम ही तो होता है, like our teachers use them interchangeably. No, actually for ionic substances the term dissociation is used. This term is for ionic substances. For molecular substances, we use the term ionization. Is that clear? Molecular substances ionize, whereas ionic substances dissociate. So, it should be clear to you, when I am talking about the molecular mass, I am talking about molecular substances. I will not talk about NaCl. For that, we have formula mass, about which I shall talk about shortly. In this, towards the end of this video, we will talk about formula mass. Molecular mass is simple. For example, if you have to calculate the molecular mass of let's say C6H12O6. This can be glucose, right? Glucose has the molecular formula of C6H12O6. Molecular mass is simple. It is the sum of the masses of all the atoms in a molecule, right? You can note this down in your book. Molecular mass is the sum of the masses of all the atoms in a molecule. So it's a simple algebraic calculation. There are 6 atoms of carbon and the mass of one atom of carbon is 12 AMU, plus how many atoms of hydrogen are there? 12. And what is the mass of one hydrogen atom? The relative atomic mass I am talking about is 1 AMU, right? And finally is oxygen. There are 6 oxygen atoms and the mass, relative atomic mass of one oxygen atom is 16. If you work this out, you will be using it in countless questions in chemistry. And it's not bad to have some molecular masses ready in your head, right? So the molecular mass of C6H12O6, which can be glucose, is 180 units, okay, in AMU. We can move over to our numerical. All right, although less likely a direct numerical will be asked about molecular masses, but it's always good to have a concept clarified using a practical application. So this is a question I have for you. Each molecule of a compound contains 4 atoms of carbon, 6 atoms of hydrogen and 1 atom of oxygen, and there is some nitrogen also. What is the molecular mass of the compound? You have to tell the molecular mass of the compound, and the options indicate that the value has to be in AMU. It has to be relative atomic mass. Now, as far as carbon, hydrogen and oxygen are concerned, okay, we know their masses, but what about this? We are given the exact mass of nitrogen. So what we can do, we can divide it by the AMU value, right? If we divide any mass value by the value of AMU, it gives us the relative atomic mass. So let us do that first. right? If you work this out, it will be approximately 28 AMU. You can verify this calculation. It is approximately 28 AMU. So now I can calculate the molecular mass of the substance. It contains 4 atoms of carbon. We know the mass of one carbon atom is 12. You should of course remember that this is the average atomic mass, right? But the abundance of C12 is so much that the average atomic mass of carbon comes out to be approximately 12. Plus 6 atoms of hydrogen. There are 6 atoms and it's 1 AMU. Is that okay? 1 atom of oxygen. So we will do 1 into 16U. And plus the mass of nitrogen we just calculated was 28 AMU. So this is simple. This is 48 plus 6 plus 16 plus 28 AMU. It's not a rocket science. You would have calculated the answer by now. The value is 98 AMU. Is that okay? So this is a simple question based on molecular mass. Now a few minutes ago I explained the difference between NaCl and HCl, that NaCl is an ionic compound whereas HCl is a covalent molecular compound. So it's basically a difference of the terms, right? If you use these two terms interchangeably, there won't be any error in the answer, but we should use the correct terminology, right? I always believe that you should use correct terminology. So for HCl we define molecular mass, for NaCl we will define formula mass. So formula mass, how does this term come? If I ask you what is C6H12O6, what is this thing? You would say that it's glucose. No, actually it's not glucose. Glucose would be if I would have brought some glucose compound in my hand and I would have asked you what is this, then you would have said okay, it's glucose. What does this represent? What does this term represent? It represents the molecular formula of glucose. Alright, because we know that glucose is a molecule, so it represents the molecular formula of glucose. Now if I ask you what is this NaCl, is it the molecular formula of NaCl? That doesn't sound right, because NaCl does not exist as a single entity in solid state, right? If you study the structure of NaCl in detail, you would learn there that NaCl consists of discrete sodium and chloride ions. There are discrete sodium and chloride ions. So I cannot use the term molecular formula. I will have to use another term, which is formula unit. Right? So just as C6H12O6 represents the molecular formula, for any ionic compound, the molar ratio of its ions will represent the formula unit of that compound, right? For example, if I take let's say SrCO3, right, strontium carbonate. So it contains two types of ions, strontium ion and carbonate ion. Right, they are already separated. So you cannot use the term molecular formula for SrCO3. It is wrong. You will have to use the term formula unit. Okay. So if I tell you to calculate the formula mass of NaCl, It is same as the molecular mass, just the terminology difference is there. So the atomic mass of sodium is, the relative atomic mass of sodium is 23U, and the relative atomic mass of chlorine is 35.5U. This comes out to be how much? This is also a value that you should remember. It's very handy. 58.5U. So can I write the formula? Mass is used for ionic compounds, and it is equivalent to molecular mass. It represents the same thing except the type of substance we are talking about. All right. So this is the formula mass. Now we can do a question based on it. All right. So let us take up a question. It's a simple question, but it will help you clarify some concept. Calculate the charge on sodium ions in 585U of NaCl. It is coulombs. Right? It is coulombs. So let's do this quickly. Units of NaCl. How many units of NaCl will be there? The total mass is 585U and the mass of 1 unit of NaCl is 58.5. All right. So there are 10 units. Okay. Now 1 unit of NaCl contains 1 sodium ion. So obviously 10 units of NaCl will contain 10 sodium ions. So there are 10 sodium ions. Right. So now is the final step. Can you tell me what will the total charge be? What will be the total charge on 10 sodium ions? There are 10 sodium ions. The charge on 1 ion is 1 unit, and it is the electronic charge, right? I hope you are clear about this. It refers to the electronic charge. The value of electronic charge is 1.6 into 10 raised to the power minus 19 coulomb. So obviously the total charge is 1.6 into 10 to the minus 18 coulomb. All right. See, these types of numericals will further help you in mole concept. When we shall learn mole concept later, these type of numericals will help you there. So that's all for today. Tomorrow we'll start with the mole part, the main part of mole itself. Till then, take care, keep enjoying, keep studying. Bye bye.